Good afternoon, everybody. My name is Lawrence Martin. I'm the Dean of the Graduate School here at Stony Brook and Director of the Turkana Basin Institute. Could I begin by reminding all of us to turn off our cell phones or put them on silent or whatever, aircraft mode, so that we don't have unnecessary interruptions. So it's my pleasure to welcome you to a lecture in the Provost lecture series. This is a lecture series we have every year which brings distinguished speakers to Stony Brook, and occasionally we feature distinguished speakers from Stony Brook. So today's speaker is Dr. Louise Leakey, who is a visiting assistant professor in the, or a research assistant professor maybe, I actually can't remember, in the Department of Anthropology in the Turkana Basin Institute here at Stony Brook. Louise was born and raised in Kenya. She has spent much of her life in the Turkana Basin. She made her first visit there when she was a babe in arms, a few weeks old, and she started to get involved in fossil hunting as a small child, and eventually got a formal education in the business and completed her PhD at University College London about 10 years ago. And since then, together with her mother, Meave, has been running the Kubifora research project, which over the last little bit more than 40 years has recovered most of the most complete fossils documenting the evolution of our genus, the genus Homo, and some of the antecedents of that genus, Kenyanthropus and Australopithecus. Meave and Louise together have worked on both the west and the east sides of Lake Turkana, although in the last few years they've been emphasizing work on the east side of Lake Turkana. And a few years ago, together with Meave's husband and Louise's father, Richard, they decided to embark on building a permanent research infrastructure up in this very remote and underserved part of the world. It's a very difficult place to get to, and a very difficult place, therefore, for scientists to undertake research, as you spend most of your time worrying about food, water, accommodation, and other things. So together in partnership with Stony Brook University, we have been building the Turkana Basin Institute, which will provide a permanent research infrastructure to support both education and research and community service projects in northern Kenya. We have the first facility almost complete, will be done by Christmas, and we hope to launch our first field school for undergraduates there in the spring. There are some brochures about the field school that you can pick up outside for those that are interested. So with that, let me turn the podium over to Louise. I first met Louise in 1979. It's hard to believe she was even born then, but she was a little girl. And she and her sister Samira used to come to the museum every afternoon after school for tea while I was doing my dissertation research. And so we knew each other in a very different role then. But for the last 5 years, I've had the pleasure of working really closely with Louise and Meave and Richard on this project. And Louise is an extraordinary person in many ways. She's a fine anthropologist, professionally trained. She's a great bush pilot. If there's no electricity, she knows how to get electricity. If the toilets don't work, she knows how to get the toilets to work. If the internet's not working, she knows how to do that. She is really an extraordinarily practical young woman, having been raised in a country where practicality is a real essential skill. When Richard started building TBI, John Flegel and I went for a visit there, and it was very clear that this couldn't be done without Louise. And at the time, Richard's health was not as good as it is, fortunately, today. And Louise was always there, and she was there to fly him places, to drive him places, to walk places he couldn't go, and to supervise things he couldn't get to. So the existence of the Turkana Basin Institute is very much as a result of Louise's effort. So she's going to share with us some experiences, both scientific and practical in nature. So with that, let me introduce Louise Leakey.
Thank you very much, Lawrence. You're almost treading on delicate territory. They're telling too many stories, something we like to keep to ourselves, no less. I was very lucky to be brought up in Kenya and actually out in the field from a very young age. And I do think that probably we're one of the few families who do stick bones together as our jigsaw puzzles. And I have 2 young girls now, and they are doing exactly what I did, and I have great pleasure in reliving my childhood with them. And they come up to Lake Turkana with us, and who knows, maybe there'll be a 4th generation, but my goodness, I hope not. We'll see. There's a lot more people involved now. Well, I'm going to show you some slides today that I put together to try and take us through some of the work that we've done in terms of actually putting ourselves in perspective on planet Earth today as a species, because I think this is something that we don't do often enough. And this is really, I think, important in today's world. So I need to find my bits and pieces. So this is really what, as a family, we've tried to understand, and I think is so important that so many of us understand in the world today, is sort of how did we get from being this quadrupedal ape to this bipedal ape that we are today, and that is exactly what we are. We do have slightly bigger brain than the others, but this is where we're headed. In fact, to be honest, this is where we are today. And that's no joke, because we are spending increasing time behind these computers. If you can imagine this game alone, the World of Warcraft, which I have never played myself and know very little about, except that 12 million users of this game exist to date, and the total number of hours that they've spent online playing this game is close to 6 million years, which is the entire time it's taken us to walk upright. So it is relevant, and I think a lot more people are spending hours and hours online, and if we want to get to the minds of the next generation, we're going to have to do something about getting to them through this medium. So what are these landmarks, essentially, that took us on this journey from four-leggedness to two-leggedness? These are some of the things that are important in terms of what we're looking for, evidence to show these critical landmarks. And we know that we stood upright or began to be upright as part of our lifestyle somewhere around about 7 to 6 million years ago, and began to use our hands to make tools. And haven't we taken tool use to extraordinary levels today? But that initially began about 4 to 3.5 million years ago, and then we have this modern body plan standing upright with Homo erectus around about 2 million years ago, and this large brain that we see on us today really came in fairly recently, 600,000 years ago. So those are key issues that many of the fossils that we find have tried to address, and trying to understand how that happened and which route it took. Was it this straight line, this trunk of a tree, which is what we all thought initially because we didn't have the fossils to show otherwise, and it's become increasingly bushy, if I can use that word to describe it. So my grandfather, his interpretation 50 years ago was that it was this very simple picture, but he had no idea what was to follow the next 50 years, which is what my parents have managed so well to do, is to fill in this picture. And it now looks, as you can see, much more complicated. And we don't necessarily have all the answers, and do not necessarily know if this interpretation is correct or not. And these fossils that they've managed to find are so remarkable, and really are the finds that have managed or have enabled us to interpret our origin. Those fossils that you see, these are some of the skulls from Lake Turkana that were found in the 70s and 80s, and they really are some of the best finds that were made. There are many more specimens that are obviously more fragmentary that help to give us a much more complete picture. What did they actually look like? That really we will never know, but artists have done a mighty fine job of making them look much more like friends that we might make. Who knows? But it's not just hominids that we find, our ancestors, but also, of course, all the other animals that existed with them. So the hominids represent about 0.1% of the fossil fauna that we find at Lake Turkana. A very few hominids. They're incredibly rare. They're sort of like the carnivores would be today in any modern day context. So they are beautiful pig specimens that we found. This is an artist's reconstruction of what some of these things might have looked like. Crocodiles, this is a crocodile skull. If you look carefully here, there's a pair of sunglasses on his nose, and you can see his teeth coming out of the side here, and his eyes. This was about over 1 meter in length, and a crocodile's body is 7 times the length of his head. They were huge beasts up there, and there were 5 different species of crocodiles at Lake Turkana 5 million years ago. A hippopotamus, you can see it died yawning. It's its upper jaw and its lower jaw. It's been dug out of the ground here. And so we begin to piece together the environment, the context in which our ancestors actually evolved. This, believe it or not, is something called a calocathea, something between a rhino and a horse. It was a perissodactyl. But these were extraordinary beasts. I mean, can you imagine if you could step back in time and have a little glimpse of the animals that existed in the past? Dinotheres, this is a browsing elephant. Big horned early buffaloes, clearly not walking through forests with those horns on their heads. And again, big baboons and other wonderful and wild forms. So this is really the context in which we came to be. So Lake Turkana, as Lawrence mentioned in his introduction, has to be the world's best laboratory for finding fossils that date back not only the past 4 million years, but way back in time. We've actually got deposits that extend as far back as the late Cretaceous, 75 million years ago. And so we feel it's incredibly important to put infrastructure on the ground at Lake Turkana as a next phase of our work in this region, to really put Kenya back on the map, or Africa back on the map, and enable scientists from across the world to come and get engaged. So the Turkana Basin Institute is named after Lake Turkana, which is this extremely beautiful lake that's 160 miles in length and has all sorts of exciting things, not just fossils that are up there. It's named after the Lake Turkana people too, traditional people that live on the west side of the lake. There are other people that live on the east side too. There are extraordinary diversity of fish, insects that aren't found elsewhere, birds. There's still some wildlife in the region. It offers a huge amount for people wishing to actually go and study and explore the region. Where it actually is, just to put you on the map quickly, you've got a map there of Africa, where the square is. We're going to zoom into East Africa, and you can see that the Rift Valley runs from the Gulf of Aden to Malawi with a western and eastern branch. And because it's a valley, a depression in the earth, water flows down from the basin margins, forming lakes and rivers the entire length of this Rift Valley. And those rivers carry sediment, which rapidly bury the bones of animals that have lived there over the past 4 million or so years. And so that is why it's such a good place to find fossils, because it's a good starting point. If you want to be preserved and become a fossil, then that's the place to go. And Lake Turkana is one such lake basin which has existed over the past 4 million years. And fossil deposits essentially run up the entire western and eastern side of this lake basin, as in the past a great river meandered through the basin and actually had an outlet to the sea. But it no longer does have this outlet. And as I said, the fossil sites that extend entirely around the basin in its entirety, you can see up in the very north you've got dinosaur deposits, you've got Cretaceous deposits up there, possibly some other ones as well, Miocene deposits, and things that are much, much more recent, some of the Holocene deposits that take us back the past 10,000 years that very little work has been done on yet. So huge opportunity for many different people to get involved in, now that we have the facilities on the ground at Lake Turkana from which people can come and do their field research. So, to show you what they look like, they are not tents. We've actually built infrastructure on the ground now, both on the west and east side of the shore. Here you can see a laboratory, and here is sort of the eating area. of one of the buildings that are up there. And this is where we are able now to hold conferences and to run the field school, which we've just alluded to. And so the Lake Turkana, the Turkana Basin Field School, which will now run from January, is going to be based right here on the western shore on the Turkwell Field campus. And we'd really encourage you to get the word out to people, because I think it's truly going to be one of those once-in-a-lifetime opportunities to have some of the real experts in this field actually teach these courses, which include modern and ancient environments of East Africa, and the archeology, the geology, vertebrate paleontology, and the paleoanthropological discoveries of the Turkana Basin. This has been offered out of the University of Stony Brook as part of the Turkana Basin Institute. This is hugely exciting stuff, and I think that it's going to become a major component of what Stony Brook becomes known for, particularly in East Africa. So that's from January to March, and please sign up fast. And information is on that website too. So I'm just going to go back to telling you a little bit about how we find these fossils. This is a cave that's in southern Africa. This is Sterkfontein Cave. And there's a picture here of my mother and myself looking at a complete skeleton, which has been in this cave for years, still hasn't come out of the ground. And I think they're keeping it in the ground to keep us in suspense. But when we went underground to look at this thing, it was very eerie. But I did think, if I had to work in these caves, there is no way I would do this work, because it's very dark and it's very difficult digging in rock, and that's why it's taken them so long to get it out of the ground. We do things quite differently in East Africa. We have a team of young men essentially drawn from the local community who walk over miles and miles of fossil deposits, 5,000 square kilometers of fossil deposits to find remains in. And we look very carefully, turning over small bits of stone, hoping that we found a fragment of bone. So this is more our style, as you can see. And the more eyes that you have out looking for fossils, the higher chance you have of finding something. But they do need to know what they're looking for, and so it takes years of practice to get your eye in. If you look very carefully at this typical surface that we're looking in, you will see a lower mandible of a hominid as it was found, and then it's gone again, right? I can do that one more time. Just to impress. But that is truly what it's about. It's knowing what you're looking for, keeping your eyes open, and then once you know that it's something important, it's got to be excavated very carefully using dental picks, brushes, and hardness to extract this thing. And you can see my mother and myself here digging very carefully, having a great time doing it, talking about all sorts of things in the process. Because it is probably the first time anybody has seen this thing that we're digging out of the ground. It is such a unique thing to do. Once we've excavated it, the sediment that we take away is put through these screens, and you're looking again for tiny fragments of bone that get caught up in these strainers. And then we can wash that sediment and do it again. So it takes a long time for us to find all the little bits of bone that help us to put together a complete skull, or those complete skulls that you saw in the photograph I showed you earlier. Now that we've got the infrastructure at Lake Turkana, we've got these let me call them prep labs, preparation labs. And here you've got a young man drawn from the local community who's actually looking through the microscope, cleaning a specimen using a dental drill, carefully taking away the sediment from the bone. And then we can put them together, stick them together carefully in pieces, and then we can begin to study the fossils, describe them, and put them into journals like Nature. Isn't that quite something, that slide? Imagine 8 Nature covers. That's all come out of Lake Turkana, and that was all the work that's happened over the past 40 years. And it really shows you how interested people are in understanding our origins and how relevant it is to everybody today. Well, the big question that I think many of us fail to ask and really should ask today is, who are we? What makes us human? What makes us such a special species? And why do we do what we do on planet Earth? And so, are we just this super intelligent upright ape? Or, we're certainly very polluting, wasteful, and don't really think about the survival of our species as a whole, and we should probably do something better about it. But the reason we do this is all down to this large brain that we have. And is that large brain a good evolutionary adaptation? I don't know yet. We'll see. That's going to be our challenge. But one thing we do know is that Homo erectus had this larger brain, and it was the first hominid to walk out of Africa 1.8 million years ago. And anything that we find outside of Africa post-dates 1.8 million years. And so we have been able to show through the fossil finds made in Africa that this is where we came from at that time. So we all have an African origin at that time. And until 30,000 years ago, there were probably at least three upright walking apes that shared planet Earth. And the fact that we're here today as a single species is a really very new situation to be in. So, I just clarify that, the Neanderthals went extinct about 30,000 years ago. And then there were these small little 1 meter high hobbit-like men that you've all read about that were found in Indonesia that were there as recently as 30,000, possibly 18,000 years ago. So the fact that today it's just us is very, very unusual indeed. So I said we all come from Africa, and not only did we evolve and move out of Africa as Homo erectus, Homo sapiens evolved there in some earlier form 600,000 years ago, and then Homo sapiens, you and I, big-brained, nothing different, evolved in Africa again. We know that also from molecular evidence 200,000 years ago, and we only left Africa 75,000 years ago to populate the globe. So it's been a very recent spread, and you can see this map that's on the wall here shows movement into the Middle East, across to Australia quite rapidly, and then across into North America as recently as 15,000 years ago. And my goodness, when people move, they do damage. And so we so rapidly probably wiped out the Neanderthals and very quickly became the only species on planet Earth in terms of as Homo sapiens. Here we go in terms of skin color, because this question comes up all the time. And I just wanted to touch on this briefly because the work of Nina Jablonski and George Chapman has shown that it's not just the fact that dark skin protects us from ultraviolet light, but it's reproductive success. It's the fact that sunshine destroys folate, and everybody knows that you're given folic acid supplements if you're pregnant because it helps your offspring not to have neural tube defects. And so if you're at the equator, you don't want the sunshine to destroy the folic acid, so you become dark-skinned. Further north, dark skin prevents you from getting your vitamin D, which is the sunshine vitamin, and sunshine vitamin and vitamin D helps to synthesize your production of calcium, and you need calcium for strong bones. And dark-skinned people, if they don't have supplements further north, end up with serious rickets. And so this is the reason behind it, and it takes the wind out of the sails of all of the people who have issues with race. It's a very recent phenomenon that we've got out, and in the big mix-up that we are today in terms of skin color, it's unusual to be and to live where we are for long periods of time. So that, I just wanted to touch on that briefly. And I think the other important thing for people to realize today is that we've only been here for a tiny, tiny window of time. And people have no problem if I tell you to think about $4.6 billion. Bill Gates is worth $53 billion or something like that. I mean, we can conceptualize money, but when it comes to time, we do have a lot more problem. And to understand how short a period of time we've actually been on planet Earth seems to be even more difficult for people to understand. And so I decided I would put a little picture together here, which with the help of my daughter, I rolled out a tube of a roll of toilet paper down a hillside here. And you can see at the very top the molten Earth 5 billion years ago. And it comes down and down and down. And this is 400 sheets of tissue paper long. And the dinosaurs go extinct here, 5 sheets from the very end. And here on the very last sheet, you can see this one square, 12 million years. That last half there is where apes walked upright. Okay, a last common ancestor with the apes, essentially. And then Homo sapiens comes in here, and the last 2 millimeters of the last square of toilet paper. And just in that very short window of time, we go from very few people on planet Earth to this extraordinary number here of close to 7 billion people on this planet. 200,000 years, 7 billion people at 80 million people a year. And these are frightening statistics. And how did that happen? You know, it's never, something happened that made this possible. And this is it. It is agriculture. It's the onset of agriculture. Suddenly, we could produce food to make us step outside of the normal constraints for population. And so our numbers were able to increase to these extraordinary levels. And contentious as it may be today, all about changing climate, but we should have been going into the Ice Age 7,000 years ago. And it's the Ice Age that just never happened. And it probably never, ever will happen ever again, so long as we're around. Turning off that freezer is very easy. Turning it back on again is nearly impossible. And so that was all because with agriculture, with the domestication of livestock, suddenly carbon dioxide levels began to rise at an alarming rate. And so we then began to affect every ecosystem that there is on planet Earth today, without exception. We began to change the water cycle. Rivers that used to take water from mountaintops to the sea no longer get to the sea in some places. In fact, there is probably not a river in the world that isn't interrupted today by reservoirs. There apparently is more water, fresh water, held up in reservoirs today than there is in all the world's rivers. And so that vital link of taking fresh water from mountaintops that absorbs carbon dioxide, takes it to the sea where these animals then absorb it and fall to the bottom. The carbon sink, the natural carbon sink, is suddenly gone. Our dependence on oil is obvious as well. It's alarming how much oil we use in a year. 31 billion barrels a year, which takes 3 million years to produce 1 year's worth of oil that we burn. I mean, these are incredible statistics. I'm not sure how long we can keep this up for, and this is what I think it's important to realize in terms of how short a period we've actually been here on planet Earth. And it's not to say that carbon dioxide levels have never been up to these high levels. They were 55 million years ago. We had a massive amount of carbon dioxide from all the methane that was produced to this event, and it was way up there. But the saving grace was the Himalayas, which came up, and again, massive mountains, as these plates collided, were formed, and these mountains, which began to erode away, the ice and meltwater acted as this massive carbon sink for us. But we can't build these mountains to try and control these levels of carbon dioxide in today's world. And so it leaves me only to bring you on to this one in terms of the great extinctions, the 5 great extinctions that planet Earth has seen. We are in the 6th right now, and it's because of our actions that we are in the 6th extinction, and we are taking out, as a result of our presence on planet Earth and our inability to preserve species, 30,000 species a year. Now, this doesn't bode well for the future, but it's a truly dramatic time, the age of man on planet Earth. So these majestic animals, this is our last essentially living common ancestor, the great apes, this mountain gorilla, whose habitats are severely threatened by people who have encroached these very small habitats that they remain on. There are only 700 mountain gorillas left in the wild today. How long are they going to be here? Will my children's children get to see them? I do wonder. These were a habituated group of mountain gorillas that were killed as a result of an illegal charcoal trade that's continuing in Virunga National Park in eastern Congo today. My husband is responsible for this national park, and glad to say the situation has changed somewhat on the ground, but for how long will it last? Because you've got a dedicated person in charge of a national park who's prepared to put their life on the line. Yes, we can hold it together for a period of time, but in the bigger picture of things, you do wonder whether it's going to last forever. Ivory, again, huge numbers of elephants have been killed because of their ivory. It continues today. It's not spoken about to the extent that it was before, but more threatening is the illegal trade in other wildlife, smaller animals, and massive amounts of wildlife are being exterminated for protein and are being shipped across the world. It's less so that the elephant is threatened than everything else, but it's still important to realize that the damage is being done. Sharks, 90% of all the sharks have been exploited, have gone from today's oceans. They have been around for 400 million years or so in the oceans. They're absolutely critical for the health of the oceans, and we're taking them out at an alarming rate today. It is absolutely devastating what we're doing to these apex predators. Tuna fish, this was in the news the other day in terms of our greed for sushi and the bluefin tuna, which fetches some $60,000 a fish. It's no wonder that they're going to be exterminated. Now, it's all very depressing stuff. And I think that's why it's so important for people to understand the impact that we're having as a species on the planet. The plastics in the oceans. This is a picture that may reflect what we know about the Eastern Pacific garbage patch, which is a huge jar of ocean currents, which essentially sweeps up all the plastics that are going into the oceans worldwide. It's something like 26 million tons of plastics end up in the world's oceans every year. Trash. And what happens to that trash? It's slowly broken down by UV, but it takes a very, very long time for this to happen. It gets into all the fish, into the toxins sort of trickle down, and we all know how dangerous that is. But I just wanted to put that into context. Here you've got the Grand Canyon, which records about half of the history of the Earth in its layers of rocks, like layers of a book or layers of a cake. Millions and millions of years of marine sediments are deposited in this fantastic landform, which essentially a river's cut down over the past 6 million years to expose these rocks. And you can just imagine what's going to be left after the age of man, the Anthropocene, is a nice layer of plastic in one of these ones. And then it's gone, and then it'll go back to being. But that's a good thing. It's a very positive thought. And I think this is something that we mustn't look at negatively by any means. And I think this really sums it up. Unless we change the direction we're heading, we might end up where we're going. But as a species, this big brain that we have, you know, we like to think of ourselves as special and different. And I think this really is our chance to prove it, to really see if we can rally together and do what it takes to ensure our survival and the survival of many other species that will extend beyond the generation that we live in. And our inability to think too far ahead in the future isn't a good thing. And we've really got to make sure that we educate the younger generation and to make sure that we don't exceed our population, the carrying capacity of the Earth in terms of our population. We're just very, very bad at controlling our numbers. And I think this is something that we've got to deal with in the future. And on that note, I will turn it over to you for some questions. I'd be very happy to answer them. All right, then you can all go home. No questions? There's one at the back. Here, I'll start at the back there. Yourself. Do you want to stand up and then I can... Okay, so her question is that the early, or apes, modern day apes, have a lot of hair on them, and what's happened between there and now? Well, good observation. There are some hairier people than others, as we all know, but in general, we are hair-free because of our activity, and in that we're in open habitats, and the fact that we need to be able to run and sweat, per se. I think that would be a big one. So if you're in the closed environments, again, it's quite a different set of constraints to when you're in more open habitats. And so when these animals started to move long distances and you're living in these hot climates, it doesn't pay to have a lot of hair on your bodies. You get incredibly hot. You need to cool down fast. So if you can get rid of the hair on your bodies, then you'll have a much better chance of keeping your temperature lower. And so that was a key. When hominids moved into these open habitats, they had to keep cool, and sweating. How long it took to evolve to sweat is another important one to deal with. We don't know for sure. Yep, down here.
Hi, Louise.
Hi, Ellen.
So you painted a really dismal picture about the extinction crisis, but a very accurate one. And you pointed at the end, in terms of solutions, to education. I'm wondering, I often get the question from students, not just about education, but what could they do right now? What actions can they take to really make a difference? So I wonder if you could highlight for us what some of the bright spots are in terms of conservation today.
Everyone got the question? What are the bright spots in terms of conservation today? That I painted a very gloomy, dark picture of the state of the planet. And you can't paint a gloomy picture of the planet and expect people to get motivated and do something about it. There has to be some hope. And I think there probably is some hope in all this. And I think as you said correctly, we do need to work with the younger generation, because there's no way we can persuade an old horse how to pull a new cart. There's no point working on that front. But with the younger generation, absolutely, and it's the younger generation who are going to put pressure on the older generation to change their cars or to turn off the light bulbs or not to travel so much. And so immediately the younger generation get it and try to get involved in a way that makes sense to them, and hopefully their lifestyles will be considerably different in the future. I think there are so many people across the world doing really positive work, and there are these hope spots. There are areas that are being conserved where good things are happening, and the oceans, protected areas are being formed where they never have existed before. National parks which are being fenced, species are being preserved, which essentially could be used to seed things in the future. To say what humans are doing is all wrong is absolutely incorrect. I mean, technology is taken to completely new levels, and I think is the hope for so much of what we will see in terms of our survival as a species on the planet here forward. And I think just the fact that there is now a means of getting people to communicate, albeit online through social media, means that there's a way to get to so many more people, get messages across to places which you could never have done that before. For heaven's sakes, we have a telephone signal at Illiret on the eastern shore of Lake Turkana, and they can call here to the States the price of a local call. They can get their internet on their smartphones. These are cattle herders in the middle of the desert. Now, things are really possible if you want them to happen, and a key part of this is communication. And I think, so we are able to reach people that it wasn't possible to do before. Who knows? It's part of the excitement of being human being today, is what we do and what we can see, and with our technology. Yeah.
Thank you for a very interesting presentation and bringing up the whole question of population control. It seems to me that there's another huge challenge, and that's how do we design economic systems that don't depend on internal growth? Because, you know, we all know a healthy economy is a growing economy. Right now we're living through a terrible recession. We've seen the pain that's caused, the housing loss, the job loss. How do we, as a species, design a system that doesn't rely on ever-increasing use of resources?
How are we going to design that system on not depending on this ever-increasing use of resources? Is it I wish I had the answer. I mean, this is one of the big challenges, which is why so many of us feel so gloomy. And the system that we're working towards today in terms of the lifestyle that so many of us lead in this part of the world isn't sustainable if everybody were to live that way. And so clearly something's got to shift. And the education is obviously key, but with education comes the desire to live this lifestyle. And so they are indeed worrying and very challenging times for governments here on. I don't know, it's one of my big concerns. Yes?
So this is just something I've thought about before, but how do you really see, assuming that humans do last in an evolutionary timescale into the future, how do you see evolution and humans interacting? Because with technology and everything, we don't really have fitness like other species per se. We work against the laws of nature and evolution in some ways, I guess, with technology.
So she's asking the questions, how do, assuming that humans exist on planet Earth for a longer period of time, say, were they to live 1 million years into the future, how do you see this sort of going about? Firstly, you're right, we live totally outside of the laws of nature. We essentially determine nature. I mean, we get to decide which species goes extinct or not, although it's not necessarily the whole species. It's down to a few people in a certain area or governments that make the wrong decisions. Yeah, we're most certainly not subjected to the laws of nature. I must say, I'm not so sure that we will be around for that million years. And as I said before, I think it would be a very good thing once we move on, because it's not to say that that will be the end of life. Not at all. It will be the end of the age of man, and then we'll see what comes next. I'm not saying that we'll be out of here in a short term. It depends on what that carrying capacity is in terms of how much food we can produce to feed this ever-expanding population, and what we can do with technology in terms of food production and communication and taking us forward. So I don't know, but I know I've just had 2 children. I've brought them into this world. I worry about it every day, and I really wonder what they're going to see in their lifetime. No easy answers in terms of, but we certainly have the ability to shape it. And I think there are going to be some extraordinary advances just in what's left of our lifetimes, but into the future as well. At the back, I can see a hand.
Yes. Hi. You mentioned that the Turkana Basin Institute is kind of like bring Africa back in the map. You did mention a couple of times that there's locals that work for this institution. So I'm wondering if you can comment a little bit on what are the positive impacts of having this institution of higher learning, this field school, in the impoverished region of the world, and whether or not having institutions of higher learning such as this in other parts of the world would be a way to stimulate those parts of the world.
Very, very good observation and comment about the fact that we've put this Institute of Higher Learning in a very remote corner of Africa, and what is the impact that it's having on the local communities where there really has been very little until then. And it is an extremely good model, and I think it's so unusual that in an area which is, as I said, the world's best laboratory in terms of fossil evidence, and these fossils to the local people who are pastoralists, who essentially have large herds of goats and roam from water source to water source, from grazing area to grazing area, across these fossil fields, these are just rocks. Yet this is global heritage, and to now have these centers there that engage the local people, that the local school can come through and see what we're doing, can aspire to being the next generation of fossil hunters, whose fathers and mothers work in the center and who bring income back to the family. It makes sense to protect and preserve this heritage, which frankly, if we hadn't done this, would be rapidly lost to the world. And so for the first time, we've got facilities on the ground that are engaging 40, 50 people on each side of the lake, many more in some cases while we're building these facilities. We've got African students from Ethiopia, Tanzania, Kenya, who can now participate as students in the field school, as researchers can come and use the facilities, where before it was very difficult to actually do their field work, can now hire vehicles, can hire tents, can actually get out there and run their own research projects on much lower budgets than have ever been possible before. And the same as scientists from across the world, and we now can engage a very vibrant community on both sides of the lake, but not just in the study of human evolution, but also in terms of studying genetics, the insects, the fish, the people, linguistics. It's a facility that we just really want to promote the science, and by having these field stations provides a tremendous and a very unusual opportunity to be able to do this in such a unspoilt in many ways and remote part of Africa. One more here in the corner.
Is there any evidence, or is it possible to get evidence as to what direction evolution is making at the present time?
Is it possible to get any evidence of if evolution is is ongoing at the present time? Well, from DNA or from any. Well, you see, I think that it all depends on time. in terms of how long we've actually been here, and when, does one species become another? I mean, we're not going to suddenly morph into something else. We've only just sort of come about. I'm sure there are modifications. There resistance to sickle cell, for instance. There are these natural processes that are ongoing. The sickle cell, if you've got sickle cell, prevents you from getting malaria. So if you happen to live in a high malarial area, like on the coast of Kenya, you have a population who are very high, have a lot of sickle cells there. And so in these little pockets, you still get these things playing out within local populations. It's harder to observe on a grander scale, but absolutely it's ongoing. And we have a better way of dealing with it for influencing it and for sort of stamping out those natural processes for the most part. But it can happen, particularly when you take away medicine and influence that we in parts of the world where that's not so common. Does that answer that? Some degree? Is there anyone else, or shall we all go on home? Thank you.